Section 4, we're going to break into two different videos. Okay, the first one will be talking about the area of regular polygons. Okay. Just keep in mind that a regular polygon is a polygon that has congruent sides and congruent angles. Okay. So like a square is a good example of a regular quadrilateral. And I want you to think of a regular polygon like a whole bunch of congruent isosceles triangles coming together. Okay. The base of the triangle here becomes the side length of the polygon. Okay. So where in the area of a triangle equation, we're going to take out that lowercase b and we're going to put an s for side length. Okay. The height of a triangle here, we're actually going to have a new vocab word, is going to become the apothem. Okay, it's like saying opossum, but with a th instead of the s's. Okay, so the lowercase h is replaced by lowercase a. Okay. And then this is just a concrete example, but we've got 1, 2, 3, 4, 5, 6 congruent triangles, which is the same as what would be a regular hexagon here if we put this together. Okay. And so we actually have to take this times the number of sides. We don't have just one of these congruent triangles. We have the number of sides. Okay, so that's where we get our equation from. Okay, I'll rewrite it down here at the bottom, I believe. But we've got a new vocab word, and that is the apothem. Okay, and that goes from the center of a regular polygon, and it is perpendicular to that side as well. Okay. And for later this section, you're also going to need to know that it bisects that side. All right. So if I'm going to draw on this, here we've got a pentagon inscribed in a circle. Okay, this is the center of the polygon. And from the center to a vertex, that technically is still the radius of the polygon, just like it's the radius of the circle. Okay, again, that's center to vertex. But the apothem goes from that same center to a side. Okay, and again, it's perpendicular and it bisects. Okay, so that apothem is that new piece of information. And then here, to find the area, we're going to do 1/2 ASN. Okay, A being the apothem, S being the side length, and N being that number of sides. Okay. Now in a regular polygon, since all of the sides are the same, this portion right here, if we would take the side length times the number of sides, that would actually be the perimeter. So we could also find the area of the regular polygon by doing 1/2 times the apothem times the perimeter. Okay, either one of these works. So these first two examples, pretty straightforward. This first one, we've got the apothem and the side length. since we've got that, just that side length, we're going to do 1/2 ASN. Remember, my apothem goes from the center perpendicular to a side. So 6.76. The length of one side here is 5.6 feet, and then this is an octagon. It's got 8 sides. So multiplying those all together, the area of this octagon, this regular octagon, is 151.42 square feet. Okay, so if you're given the side length, 1/2 ASN. Okay, but this next example here, we are given the perimeter, so I'm going to go ahead and use 1/2 apothem times the perimeter. My apothem is 10.46. My perimeter is 76. And that gives me an area of 397.48 square inches. Okay. But we're going to run into some where you will need to use a special right triangle pattern. Okay. We are only going to focus on squares, hexagons, and maybe equilateral triangles in our practice. Okay, we're not going to get into like pentagons or octagons because that would use trig, not just the special right triangle patterns. Okay. Now with the hexagon, okay, each one of these interior angles measures 120 degrees. Okay, and this radius here bisects that interior angle, which is why we get to use a 30, 60, 90 pattern. Okay, the apothem is perpendicular. That gives us our right triangle. 120 divided by 2 is 60. Okay, and here we know our apothem is 5 radical 3. This is our A to A radical 3. Okay, and that pattern tells us that down here I'm going to have a 5. Remember, I said the apothem bisects that side, so if one part is 5 here, the other part's 5. That helps us find the side length of 10. Okay, and so now we've got all the pieces of information that we need. 1/2 ASN. Our apothem was given to us. We found our side length to be 10, and the hexagon has 6 sides. Okay, so we take 1/2 times 5 times 10 times 6, we get 150. And then we can tag on the square root of 3 at the end. Okay, yes, you will have to know how to do these and find the exact answers. Okay. All right, next is a square. Okay, now a square technically is a regular polygon, but that doesn't mean we have to use 1/2 ASN. Okay, a square we can use just base times height since it is a quadrilateral or a parallelogram. Okay, but since a square has 90-degree angles, the radius here cuts that in half. And if we draw our apothem in, that gives us a 45, 45, 90 triangle. Okay, so here our radius is 7 centimeters. Okay, our apothem and that portion of the side are congruent, but also remember that apothem bisects the side. Okay, our 45-45 pattern, we've got our A radical 2, which means that we need the length of our legs here. Okay, dividing 7 by the square root of 2 gets me 7 radical 2 over 2 for each of these. Okay, which means one side, we add 7 square root of 2 over 2 to itself, one side length is just 7 square root of 2. Okay, so to find the area, I'm going to take 7 radical 2 times itself because the square has 4 congruent sides. And when I do that, I get an area of 98 square centimeters. Okay. We're going to do examples 7 and 8 together. I want you to try 9 and 10 on your own. Okay. We want the exact area of a square. So we've got a square. This is going to be like the last example we just did. Okay, with a radius of 8 radical 2. So from the center to a vertex, this is a terrible square. Center to a vertex is 18 radical 2. Okay. And to get my special right triangle, there's my apothem. So this little triangle here is what's going to give me my 45, 45, 90. Okay, squares, you will always be using a 45, 45, 90. Okay, if my radius here is 18 radical 2, that is my hypotenuse of my 45, 45 triangle. Okay, which means both of my legs are going to be 18. Now, why is that helpful? Well, I know my apothem is 18. Okay, but remember the apothem bisects one side. So since half of that side is 18, one side is 36 inches long. Area of a square, we can just do side times side. Okay, and 36 times 36 gets me an area of 1,296 square inches. Okay. And number 8, we want the exact area of a regular hexagon. So a 6-sided, make this as regular looking as possible. Okay, and we have a radius. So again, radius goes from the center to a vertex of 8 centimeters. Drawing the apothem gets me my right triangle, and remember hexagons are your 30, 60, 90. Okay, right now I don't know my apothem. That's what I'm going to use this special right triangle pattern for. Okay. What I'm given, that radius of 8 is actually the hypotenuse of my 30, 60, 90. Okay. Using that pattern, half of my side is 4 units. but then the long leg is what I need for the apothem. So 4 square roots of 3. This is what I'm looking for to find the area of this hexagon. Okay. My apothem we just found was 4 radical 3. One side, this is 4, that means this part is 4, so one side is 8 centimeters. And a hexagon has 6 sides. Okay. 1/2 times 4 times 8 times 6 gets me to 96, but don't forget the square root of 3. Okay. Again, try 9 and 10 on your own. Okay, we can go over them together in class before we get to the practice.